welcome to this channel. My name is Sumit Bhushan, and on this channel we discuss about physics. So in this session we are going to discuss about acceleration. We will define acceleration. So what is acceleration? So acceleration is basically a change in the velocity of an object or a particle of an object is called acceleration. So now remember, velocity, since velocity is a vector, acceleration is also a vector. Moreover, since velocity is a vector, a change in it can involve a change in velocity or a change in direction or both. What do we mean? See, if a particle is moving like this on a straight line, so let us say its velocity now is 5 meters per second at time t1. Okay. Now at other time t1, its velocity becomes 3 meters per second, but the direction remains same. It is still moving in the plus x direction. Okay. But since the magnitude has been changed, we say that the particle has undergone acceleration. Second situation is, let us say the particle is moving on a circular path with no change in its magnitude of the velocity. But since it is on a circular path, at every instant, for example at t1 it is moving in this direction, at t2 it may be moving in this direction, at t3 it is moving in this direction, and so on. So although in the case of uniform circular motion, in the case of uniform circular motion, we will come back to this uniform in a bit, but for now let me write it down. In the case of uniform circular motion, the velocity, the magnitude of the velocity does not change. However, its direction of motion, its direction keeps changing. So in this case also, the particle is said to undergo acceleration. Okay. Third case may be when the magnitude as well as the direction is changing. Right. So for example, a particle is moving at 5 meters per second in this direction, then it changes the direction as well as the magnitude of the velocity to, let us say, 4 meters per second. Okay, direction has also changed, so this is also acceleration. So now let us define acceleration, the term acceleration mathematically. So there are two quantities of interest. One is average acceleration, and another one will be instantaneous acceleration. So first, just focus on average acceleration. So it is defined as, let us say, we are discussing it in one dimension. Okay, so let me write it down. For a one dimensional motion, average acceleration is equal to v2 minus v1 upon t2 minus t1, or delta v upon delta t. Now what is v2 and v1? v2 is the velocity at time t2, and v1 is the velocity at time t1. So this is average acceleration. Okay. What will be instantaneous acceleration? Just like in the case of instantaneous velocity we discussed in a previous video. So here instantaneous acceleration or simply the acceleration. Okay, so acceleration is defined as limit of delta t tending to 0, delta v over delta t. So that becomes equal to dv over dt. Okay. So we can also write, since v is itself, so v being the instantaneous velocity, so d by dt of v itself, remember, is dx by dt, where x is the particle's position. So remember this we have written as, since v is equal to dx over dt. So we can write the acceleration as the second derivative of position with respect to time. So from here we can see that average acceleration will be, the instantaneous acceleration will be, so if we are having a velocity versus time plot, let us say it is maybe like this one. Okay, I am just drawing a general plot. So in this case, at any instant, let us say this instant at t1 maybe. So at this instant the instantaneous acceleration will be the slope of the curve, and from mathematics we know that slope is the derivative. Okay, so like that. Fine. So now let us I think that is all about instantaneous acceleration and average acceleration. So I hope it is clear from the discussion here. In the next video we will be having some of the practical examples. Okay, so thank you for listening to this video, and good luck with your studies.